Hello everyone. Today's topic is merge sort. So let's go into the introduction of merge sort. Merge sort is one of the sorting algorithm where it works on dividing the unsorted array into subarrays recursively, and then we would sort the unsorted arrays, and then the results obtained on each subarrays are then merged together to give out one sorted array. Before going into the depths of merge sort, let's see what is the design technique or the approach for this algorithm. So for merge sort, we use divide and conquer design analysis, where in divide and conquer design technique has three major steps, that is to divide the given problem and then conquer the bits of the results and then combine the results to form one output. So some of the examples of divide and conquer technique is quicksort and merge sort. So we know that quicksort is also one of the sorting technique. It is the most efficient sorting technique, which is also known as partition exchange sort. It starts by selecting the pivot value that is at the starting of the array from an array, followed by dividing the rest of the array elements into two subarrays. So the partition is made by comparing each of the element with a pivot value. It compares whether the element holds greater value or lesser than the pivot value and then sorts them recursively. So in merge sort, uh, as we know that it's one of the sorting algorithm that sorts an array by making comparisons. It starts by dividing an array by into subarrays and then recursively sorts each of them after the sorting is done, and it merges the subarrays outputs of the subarrays to give out one single output. So now let's understand what is merge sort with one simple example. Merge sort, here we would recursively split the array into smaller subarrays until it is no longer able to divide into one of the subarray. So then we are gonna sort the subarrays and then we would merge the arrays to give out one output. So I have taken numbers 38, 27, 43 and 10 as our example. So now let's see it's working. As we were discussing, firstly we need to split the given unsorted array into subarrays. So the given question is divided into subarrays. So this is the left half of the given question, and then this is the right half of the given question, and then at the second step we would still move on with the splitting of the array into two equal halves. So here the left half of the first unsorted array is divided. So the actual sorting is being performed as the array is completely being partitioned, that is being formed into subarrays. So now we would compare the two elements, the two subarrays. So we are going to compare both 38 and 27, that is which is lesser. We are going to place it first and then the other. Similarly here, and at the step 4 we should merge the array. Similarly we should even compare the both subarrays. So here we are comparing the subarrays and then placing it as the same. So to understand how merge sorting technique works, we need to first understand its algorithm. So here we have two parts in a single sorting technique, that is in merge sort. That is merge sort, it is to divide the unsorted array into subarrays, so on recursively until it couldn't be further divided, and merge is the operation, that is the sorting technique inside it, and finally to get the we get the output from the merge And here in merge sort we have three parameters, that is the array, that is the unsorted array, and low, it is the first index position and of the array, unsorted array, and high is the last index position of the unsorted array. If low is lesser than high, we need to find mid. So how we find mid? By adding both low and high and then dividing them, and the position and the value we get is mid. So now we will sort, now we would divide the unsorted array into two parts, that is the array which starts from the lowth index to the mid index, whichever is there in the mid index. And similarly, this is, let us consider this as left half of the array, and we would construct the same right half of the array from the mid plus 1th position to high position, and we would do the same until we further we can't divide the unsorted array. As if you refer the example, you would get into this merge. So merge has a merge, and then we would call merge at last. So now the second most part of the merge sorting technique is to merge the divided parts. So this is the actual working of the unsorted array, which would make it a sorted array. So here it has four parameters, that is the array low, mid, and high. So we would initialize the k and I as the lowth index position, and j is the mid plus 1th index position, while the ith position is lesser than or equals to the mid position, and even the jth position in the unsorted list array is lesser than or equals to the high index position. We would a of ith position is lesser than the a of jth position, that is here we are checking the contents of the a of I and a of j. If a of I is smaller than the a of jth content, then we would add the content, that content of that is in the ith position, into the new array, that is the result, and then we would increment k and I. If it is not satisfying, then we would obviously consider this is smaller and this is larger, so the smaller one we would move it on to the result list, that is the sorted array. Now we would check the ith position. If it is lesser than the mid position, if it is lesser than or equals to the mid position, then the content of a of I is directly put on into the result array, and then we would increment k and the position of k and I. Similarly, if the jth position is lesser than or equals to the high position, then we would add the contents of the a of jth position into the sorted array, and then increment both k and j, and then we would finally return the sorted array. See some advantages and disadvantages of merge sort. Stability. Merge sort is a stable sorting algorithm, which means it maintains relative order of equal elements in the input array. Guaranteed worst case performance. Merge sort has a time complexity of big O of n log n, which means it performs even on larger data sets. Parallelizable. It is a parallelizable sorting technique, which means it can be easily parallelized to take advantages of multiple processors or threads. Let's see some disadvantages. Space complexity. Merge sort requires additional memory to store merged subarrays during sorting process. Not in place. Merge sorting is a not in place sorting algorithm, which means it requires additional memory to store sorted data. This can be disadvantage on applications which are concerned with memory usage. Not always optimal for small data sets. For small data sets, merge sort has a higher time complexity than other sorting algorithms like insertion sort or any other. This can result in slower performance for smaller data sets. However, merge sort is preferable for larger data sets. Merge sort complexities, that is the time complexity here. Best case complexity, average case complexity, worst case time complexities, all are of same, that is big O of n log n. It occurs when there is no sorting required, that is the array is already sorted, the best case time complexity of merge sort is big O of n log n. Average case complexity, it requires when an array elements are jumbled order, that is not properly ascending or not properly descending in the required sorting. The average case time complexity of merge sort is similar, that is big O of n log n. Worst case complexity, it occurs when array of elements required to be sorted in reverse order. This means if you suppose you have a sort an array elements in ascending order, but its elements are in descending order, the worst case time complexity increases. So I would conclude that merge sort is an efficient sorting algorithm that uses divide and conquer technique to break down the problem into smaller subproblems by recursively dividing it, sorting it, and merging the achieved outputs into one single output. It achieves a time complexity of big O of n log n, making it a powerful tool for sorting large data sets. Its stability and predictability further contributes to its popularity in various applications. Thank you. I hope the video was informative.